In this question, our signal x of t consists of two sinusoids. So a cosine and a sine with two different frequencies. And then we pass that signal through an ideal low-pass filter with a cutoff frequency of 1,200 radians per second. And the question is to find the power of the filtered signal. So after filtering, how much remains and what's the power? So if we were to look at the frequency of our two signals, we have a signal of frequency 2000 and a signal of frequency 5000. So that's 2000. Let me move that up a little just to make it clearer. So 2000 and 5000. And this axis is omega in radians per second. Okay, so these numbers here between the brackets, they represent omega. So we have a cosine and a sine. So the spectral lines, that's our cosine and that's our sine. So the relative weights are 4 and 6. So it doesn't really matter what the amplitudes of those are. So remember that cosine and sine both give you impulses in the frequency domain. Obviously you'll have positive and negative frequency, but if we're looking at the positive frequency axis, then this corresponds to that, and this impulse corresponds to that. Now that's then passed through a low-pass filter with a cutoff frequency of 1200 radians per second. So that's somewhere here. So our low-pass filter will have characteristic or a frequency response that looks like that. So obviously that's symmetric. So this is the pass band. Everything between 0 and 1200 radians per second is the pass band. So that is allowed to pass. Everything beyond that, so everything from 1200 onwards, is blocked. So this is all blocked by the filter because it's a low-pass filter. And it's an ideal low-pass filter, but that doesn't really make a difference. Both of these components are part of the blocked portion. So both of these will be blocked by the filter. So the filtered signal is simply 0, and therefore the power of the filtered signal is also 0. So there's no trick in a question like this. You simply need to, you don't even need to sketch it. You can simply look at that and realize that it's lower than the smallest of those, and therefore nothing passes through it, and therefore the filtered signal has 0 power.